We are still working on 12.2. What we're going to do now, if it'll open, here we go, hide, lasso, delete, lasso, copy, I don't think I got all of it, paste, oh, so close, negative exponents. Okay, let's do this. What we have here is right actually under the 0 exponent. It's a negative exponent right here. So I'm going to go and write the rule, but that's going to be the one that we're looking at right there. So for our negative exponents, there's actually two different ways that you could see them. And this is what it would look like. If we have something raised to a negative exponent, I would usually just kind of ask myself, is this in fractional form? No, it's not in a fractional form. Because it has a negative exponent, I need to put it into fractional form. Technically, it would be, do y'all agree? You can write anything over 1, right? So technically, it would be up top. And when you first see it, though, it doesn't look like it's in fractional form. What I mean by put it in fractional form is bring it down to the bottom. What this does is it makes our m positive. Okay, and then similarly, if we have something that you could tell is in a fractional form and it has a negative exponent and it is actually located in the denominator of a fraction, what you would do is, instead of in the previous example bringing it to the bottom and the power changing, what we do is we would bring it up top and the power changes. Okay, so let's do a problem. Say we have 3 to the negative 2 power. I'm going to say this because I think it's very helpful. A correct answer will never have a negative exponent. So if you're working on a problem and you notice, it's going to take, so many different steps depending on which step you understand the most or you see the first, you'll evaluate that. And they'll all take a different amount of steps for everybody. There's no just one way to solve these. But if once you believe you've finished your problem, you are actually not done if anything still has a negative exponent. Okay, so a correct answer will never have a negative exponent in it. If you see this and it tells you to evaluate it, you cannot enter that into your calculator. And so that's why we would use this rule. And the rule told me that if it's not in fractional form, I'm going to write it in fractional form with my term in the denominator. So what I would actually have is 1 over your base goes down to the denominator and your exponent goes from a negative to a positive. Now, as far as the homework's concerned, because that exponent is just a 2, it probably would go ahead and tell you to evaluate that. And what you would do is what we learned in our first video for 12.1, which was 3 squared is 3 multiplied to itself 2 times. So 3 times 3 would be 9. And that would be your final answer. Okay, so let's do an example where we have 1 over x to the negative 4th. I didn't like either of those. So I would ask myself, is this in a fractional form? And it is. That's what tells me I would be looking here. And that rule shows me that if I have a base being raised to an exponent and that exponent is negative, what you would do is you would bring it up top. Very untechnical term there, y'all. But we would move it from the bottom to the numerator. And what that does is that changes the negative exponent to a positive exponent. Okay, so there is something else I want to show you. I always technically looked at it as kind of a shortcut in a way. I'm going to come up some, y'all. We'll call this 3. Say inside of parentheses, that's a big parenthesis because it's going to be like in a fraction form. I have 1 over 6, and it's being raised to the negative 2 power. That does look really similar, right, to the power rule that we did, which was if you had something in a fractional form with a term on the top, term on the bottom, however many there may be, and it's all being raised to a negative power. It's all being raised to a power. Didn't the top get the power and the bottom get the power? You could apply that here, and what you would actually have is 1 to the negative 2, and then you would have in the denominator 6 to the negative 2. But then you would notice, hey, I have negative exponents. They actually need to change from the top to the bottom and the bottom to the top. And so what I'm doing is I'm kind of taking about a step and a half or so away. If you see parentheses and a fraction, and then on the outside for the exponent, it's negative, what you do is just flip your fraction and your exponent becomes positive. Now we would look at this problem and think of that power rule. And what we would do is everything in the top would get this power and everything in the bottom would get the power. So 6 squared over 1 squared, that would just be 36. Is that good? I'm trying to think if I've got another example. No, that looks about it. Okay, just so videos are easier to upload, I'm going to stop this one. I'll come back with a quotient rule problem. Let me know if y'all have any questions, okay? Thanks. Bye.